Hello, guys. Hope you are doing well and having a great time. Also, don't forget to stay at home and stay safe. That's very important. This is class 9 science lesson 2. Okay, so today's lesson is all about simple machines and what are they, uh, what is their mechanical advantage, and how do we use them, and where we can find them and all that. So let's start. So it is very important to know that all machines, doesn't matter how complex they are made from one or more of these simple machines. And obviously there are 6 types, and as you can see in the picture below, uh, the 6 types are right there. For example, levers, pulleys, pulley, wedge, screw, wheel and axle, and inclined plane. Okay, let's start with lever. What is a lever, and did I ever use a lever? Of course you have. For example, when you played a seesaw with one of your friends, you actually used the lever. Or when you removed a nail from anywhere with a hammer, you use the lever. Okay, so what is a lever? A lever is a simple machine that has a bar, and also it has a fixed point. That fixed point is called fulcrum. So it is very important to know that we have a fixed point called fulcrum, and the lever basically is composed of a bar. Okay, so there is, and we have 3 classes. It is very important to ask yourself, well, why we have 3 classes? Based on what? These classes are based on the placements of fulcrum, the load, and the input force. So, based on the placement, the place of the load or the input force, so the load is the output force, just so you remember, and the place of the fulcrum, we decide which class of lever we have or we are talking about. Okay? First class lever. There's a few things you should know right away about them, like the place of the fulcrum. The fulcrum is always between the load, in a bracket, the output force, and the input force. So remember, this class, always the fulcrum is between the load and the input force. And another thing you should know about them is that we can change the place of the fulcrum. What does this mean? It means that depending on the location of the fulcrum, the first class lever can be used to increase the force or increase the distance. So you can increase your force or increase the distance according to the position of the fulcrum. Okay, if I want to talk about these 3 following slides, I will have to tell you what is a mechanical advantage. What is a mechanical advantage? Well, mechanical advantage is a number that tells you how many times a machine multiplies force. A number of times a machine multiplies force. Also, it's very important for you to know that mechanical advantage does not have a unit. To know what is a mechanical advantage, you will have to know them, because the following slides we will talk all about the mechanical. Every one of these simple machines have mechanical advantage, so you will have to know them. Okay, let's say that the fulcrum is closer to the input force than to the load. In this case, you will have a mechanical advantage of less than 1, because, and although the output force is less than the input force, the distance will increase. The distance increase. And so remember, a machine that has a mechanical advantage that is less than 1 will reduce the output force, but can increase the distance and objects move. So mechanical advantage less than 1 will help you move object from a very far away distance. And figure A illustrates the whole idea behind the position of the fulcrum. As you can see, the fulcrum is very close to the input force. The input force could be U, and it is very far away from the load. Okay, what if we put the fulcrum exactly in the middle of the bar? And now I know the image or the figure is a little bit tricky. You feel like the fulcrum is a little bit near the load, but we will see it as if it is in the middle. So if it is in the middle of the load and the input force, then in that case it will have a mechanical advantage of 1. What does it mean? Well, it means that the input force is equal to the output force, the load, just like a seesaw. At this time, we will change the position or the location of the fulcrum, and we will make it closer to the load. When the fulcrum is closer to the load than to the input force, the lever has a mechanical advantage of greater than 1. Now we will have to know what will happen when the mechanical advantage is greater than 1. A machine that has a mechanical advantage that is greater than 1 can help you move or lift heavy object, because the output force is greater than the input force. This is very important. So you need small force to lift heavy object. That's the use of mechanical advantage greater than 1. Second class levers. So in this class, the load is between the fulcrum and the input force. So the position of the load is between the fulcrum and the input force. So the second class lever do not change the direction of the force, the input force. Unlike the first class, we said it always change the direction of the input force. This is their difference. And also the location of the fulcrum is the second difference. You should know it. But there's another thing you should know about it, because this lever does not change the direction of the input force. It actually allows you to apply less force than the force applied by the load. Because the output force is greater or more than the input force, you must exert or apply the input force over a longer distance. Okay, second class levers, mechanical advantage. Well, if you want to talk about the mechanical advantage of the second class levers, you will have to talk about the position of the load, the location of the load, and the location of the fulcrum. Since the load is very close to the fulcrum, the mechanical advantage is greater than 1. Why? Because the closer the load is to the fulcrum, the more the force is increased. So if the load is close to the fulcrum, the force will increase, and if the force increased, that means you will have more mechanical advantage. That's the whole case. So the mechanical advantage is greater than 1. You will have to remember. You will have to remember another thing, which is the location of the distance between the load and the fulcrum is very short. As you can see in the figure B, you can see the load. If you compare between the input force and the fulcrum and the and the load and the fulcrum, you will realize that the distance between them is different, and that makes difference between the whole case of mechanical advantage. So remember, the mechanical advantage of the second class lever is greater than 1. Why? Because we consider the location of the load to the fulcrum. The location of the load to the fulcrum. Okay. Let's move to the third class lever. It is very important to know that the input force is in the third class levers is between the fulcrum and the load. Now, if you compare it to the second class lever, you will understand that the load was between the fulcrum and the input force. But in this class, the input force is between the fulcrum and the load. Now, it is very important to know that this class of levers do not change the direction of the input force. Therefore, the output force is always less than the input force. The diagram below illustrates the whole idea behind it. You can see the load in one hand, the fulcrum in the other part of the diagram, and the input force right near, not in the middle again, near the fulcrum, but it is in the middle. So that's the whole idea behind it. You should remember that it does not change the direction of the force again, just like the second class levers. Also, the input force is between the fulcrum and the load. Okay, it is very important to talk about the mechanical advantage of the third class levers. The third class levers has a mechanical advantage less than 1. Why? Because the force is decreased. By the other hand, this class of lever increases the distance through which the output force is exerted. So it's very important to remember. It decreases the force but increases the distance. So remember, it decreases the force but increases the distance. Now I want you to look at the figure that it is right there. You will realize that the position of the load, that man is trying to catch a fish, obviously. The position, you notice the position of the fulcrum, and also the effort or the input force that the man is doing. That man could be you, by the way, so it is not very far away from us. We can go to fishing and use a lever, which is the instrument that is used for fishing, and the fish that you are catching is the load. The person who is catching the fish, the hand of that person is actually the input force or the effort, and the point that you are holding or making the instrument stable is the fulcrum. Okay, let's make a quick review. I want you to look at each one of those classes, the three classes, and notice the position of the load and the effort, which is the input force and the output force, and the fulcrum, the first class, the second class, and the third class. I want you to imagine that, imprint that image right into your brain. You will have to know the position of each one of those: fulcrum, load, and the input force. Okay, let's move on. Second types of simple machines, which is a pulley. A simple machine that consists of a wheel over which a rope, chain, or wire passes, and basically this is how it is made. How does pulleys work? This is the $1 million question. Well, uh, load is attached to one end of the rope, and the input force is applied to the other end. So one end of the rope is the load, the other end is the input force. This is how the electrical elevator that we use all everywhere every day works. And believe it or not, it is a pulley. Let's talk about the types of a pulley. The first one is fixed pulleys. Fixed pulleys is attached to something that does not move. By using the fixed pulley, as it is obvious from the picture, it has an anchor and you can lift things with it. So by using the fixed pulley, you can pull down on the rope to lift the load. So the tiny human right there is actually making effort to lift that load. And believe it or not, a fixed pulley, the size of the output force is the same as the size of the input force. That's why it is the mechanical advantage is 1. Second type of pulley, you guessed it, the movable pulley. Movable pulleys are attached to an object being moved. So movable pulley is not anchored, is not fixed, it is actually moving. Movable pulley does not change the direction of the force. Movable pulley do not increase the force. Also increases the distance over which the input force must be exerted. Movable pulley moves up with the load, so it changes the direction as the load is lifted. The mechanical advantage of this movable pulley is 2, so it has a greater mechanical advantage, but it moves with the load, so it is a movable pulley. What will happen if we combine the movable pulley with a fixed one? You guessed it, block and tackle. When a fixed pulley and a movable pulley are used together, the pulley system is called block and tackle. The mechanical advantage of a block and tackle depends on the number of the rope segments. Now, the image that I have put it right there, the segments are 4, so the mechanical advantage is 4. Though you will have to know that to lift an object 1 meter up, or to lift a load 1 meter up, you will have to have 4 meter of rope. So it is very important to know that, and to know that the mechanical advantage of this block and tackle system or this pulley system is 4. Let's talk about wheel and axle. A simple machine that consists of two different sized circular objects. And what are the examples of wheel and axle? Well, doorknob, steering wheel, wrench are all examples of wheel and axle. Now you'll have to know that when a small input force is applied, when you apply force on the for example a steering wheel or a doorknob, you will actually rotate. The wheel is rotating through the circular distance. As the wheel turns, so the axle, uh, but the because the axle is smaller, the inner part is axle, so it is smaller. It rotates through a smaller distance, which makes the output force larger than the input force. That's the whole idea. You will have to know that the smaller one is the axle, the larger one is the wheel. Remember, the smaller one is the axle, the larger one is the wheel. Okay, let's talk about the mechanical advantage of a wheel and axle. How can we find the mechanical advantage of a wheel and axle? It can be found by dividing the radius, the distance from with the center of the edge of the wheel by the radius of the axle. What does it mean? It means that mechanical advantage of the wheel and axle is the radius of the wheel and divided by the radius of the axle. Now the arrows right there in the figure shows you where is the radius of the wheel. It is the larger part. The smaller circle is the radius of the axle. The input force could be applied through any the gray part, obviously, and the wheel is shown right there, and the axle is also shown right there. And the mechanical advantage of the wheel and axle could be found by dividing the radius of the wheel um, by the radius of the axle. Let's have a quick homework. This is your homework. So I will read the question. The question says, what is the mechanical advantage of a wheel and axle if the radius of an axle is 3 centimeters and the radius of the wheel is 15 centimeter? So try to answer this question and put your answers in the comment section down below. I'll try to see them and check them, and I hope you all get it right. Also, you can change the numbers, any numbers you like, and practice. So let's talk about the mechanical advantage of the wheel and axle. Now, it is very important to know that the turning of the wheel will result mechanical advantage greater than 1. Why? Because the radius of the wheel, the bigger part, is greater than the radius of the axle, the small part. So the radius is larger, this of the wheel is larger, this result of mechanical advantage greater than 1. Okay, so very good. Now let's talk about inclined plane, another simple machine that is composed of a straight slanted surface. Is a machine that is a straight slanted surface. So a simple machine that is a straight slanted surface which facilitate the raising of the load. It makes lifting things easier. Instead of lifting it, you can actually drag it. Now the force that is needed needed to load something by using the inclined plane is very, very little. But in the other hand, the distance will increase. So remember, this how the inclined plane works. It needs less input force, but it actually, the distance increase. So the input force decreases, the distance increases. Okay, so as it is shown in the figure, now he's actually using an inclined plane, and he is lifting or dragging or pulling um, a load, but I'm pretty sure his job is much easier because he's using a simple machine. Now the two images are talking about the same thing. One of them is actually being used, which is the inclined plane, and the other one is waiting to be used. How can we find the mechanical advantage of inclined plane? Okay, there is a rule also. The if you the basically, the greater the ratio of an inclined plane's length to the heights, is the greater the mechanical advantage. So how can we calculate it? Well, MA, which is mechanical advantage, IMA, which is inclined plane mechanical advantage, could be calculated by dividing the length of the inclined plane now to the height of the to which the load is lifted. As it is shown right there in the image, there we have a load. We can use a force on the load. The inclined plane has a length, which is the L, and the height, which is the H. So IMA, which is the inclined mechanical advantage, is simply could be found by dividing the length by the height. And this is how it works. Let's move to the quick quiz. The first question says, a wheelchair rump is 9 meter long and 1.5 meter high. What is the mechanical advantage of the rump? The second question says, what is the mechanical advantage of a rump that is 12 meter long and 4 meter high? Now, the second question has an illustration figure, and I already gave you the answer in the form of a multiple choice. Now, I expect each and every one of you to answer these questions in the comment section down below. So I will check it. Let's move on to another type of a simple machine, which is wedge. What is a wedge? A wedge is a pair of inclined plane that moves. Again, what is a wedge? What does it mean? Well, it means that wedge is a simple machine that is made up of two inclined planes, and that move often, used to for cutting. For example, a knife is a wedge. Axis is a wedge. Anything, basically, we use wedge for cutting. So it is composed of two inclined planes, and it actually can move and cut things. So a wedge applies on an output force that is greater than input force. So the output force is greater than the input force, but you apply the force over a greater distance. As I said again, the distance increase, the input force decreases, but the distance increase in this case. Chisels and knives are two types of wedges, and in the next slide we will talk about the mechanical advantage of a wedge. Mechanical advantage of a wedge. Okay, before I talk about the mechanical advantage of a wedge and how can we find it, well, let's ask ourselves a question: why knives and cut better when you sharpen them? Not only knife, anything that it is used for cutting, it is better when you sharpen them. Why? Because simply, longer and thinner the knife, the wedge is, the greater its mechanical advantage is. Simple as that. So how can you find a mechanical advantage of a knife? Let's say any type of knife you have. How can we find the mechanical advantage of that knife? If you want to find the mechanical advantage of a wedge, you will have to divide the length of the wedge, the knife in that case, by the greatest thickness. So I gave there's example right there. The thickness of that wedge is 2 centimeters, and the length is 8. The length is 8 centimeters, and I have the division. The result is 4. So 8 divided by 2 is 4. Now prepare yourself. The next slide is a quiz, so be prepared. Let's practice mechanical advantage of a wedge. Now you can see in the bottom of this slide you can see the equation. The equation actually says that you can find the mechanical advantage of a wedge by dividing the length to the thickness. The picture right there. The thickness is 2 and the length is 6. You divide it and it's 3. But the question is in the upper part. The question says, what is the mechanical advantage of a wedge with a thickness of 5 centimeter and the length of 15 centimeter? Can you find this one? This is actually is for you to find, and you can. I will see it with the other quiz, and I will check it. I will check this one with those. So please try to practice, and good luck. The last type of a simple machine is screw. It is a simple machine that consists of an inclined plane wrapped around a cylinder. Now I want you to look at the picture in the background, and you will see a pen and a paper wrapped around it. So the pen is actually a cylinder, and the paper is the inclined plane. Look at it carefully. The paper is the inclined plane and the pen is the cylinder. Now you already know that we talked about the mechanical advantage of all the simple machine, and we will talk about the mechanical advantage of a screw also. How can we increase the mechanical advantage of a screw? Well, the longer the spiral of a screw is and the closer the threads are, the greater the mechanical advantage is. Why? Well, because the longer the inclined plane is compared with the height, the greater the mechanical advantage is. So I want you to unwind that paper around that pencil. If you could unwind that, you will see that the inclined plane, the paper is very, very long, and the slopes of that paper is very gentle, has a gentle slope. So the screw is the same. If you unwind the inclined plane of a screw, you would see that planes is very, very long and has a gentle slope. Now I want you to remember that the longer the inclined plane is compared with the height, with its height, the greater the mechanical advantage is. Also, remember, a jar lid is a screw that has a large mechanical advantage. Though it's not mentioned in your book the way to find mechanical advantage of a screw, but I said it. I thought it would be very, very useful for you to know the way because it actually illustrates the whole idea behind it. So the mechanical advantage of screw could be found by dividing the length of an inclined plane wrapped around the screw by the length of the entire screw, just like it is written right there, the length of the inclined plane, the blue part, divided by the length of the screw. This is how you can actually find the mechanical advantage of a screw. So, okay, and you can practice, you can put numbers, any numbers that you can find, and practice on it. It would be good for you. The following links could be very helpful for you to understand the whole idea behind simple machines. So check it out, and you it might be useful. And good luck. In the end of our lesson, I hope you are all well and having a great time. Stay at home, stay safe, enjoy your time, and be well. Thank you for your attention.